Okay, so now I want to continue on with Chapter 3, and in particular, this video is going to correspond to sections 3.3 and 3.4. So in this section, we'll basically be introducing the final 4 inference rules for a total of 6 in Chapter 3, and then working through examples of proofs that use all of those rules. So the first rule that we're going to introduce right now is modus tollens, and we're going to abbreviate that with MT. And what this rule says, this one also works with a conditional. Remember, modus ponens works with a conditional. The other thing that modus ponens needs is the antecedent, right? If you have a conditional and you have the antecedent, you can derive the consequent. Modus tollens works with a conditional, but you need something different in addition to the conditional. You need the negation of the consequent. And if you have those two things, you can derive the negation of the antecedent. Okay? The next rule is Disjunction Introduction, and we'll call that DI for short. And what this rule says is that if you have a statement, and this one is easy, you can always apply DI, because you can apply it to anything. So this just says you have to have some statement phi on a line, and you're always going to have a statement phi on a line. Except in Chapter 3, when we do proofs with 0 premises, there might be, a moment for those proofs where you don't have a line yet. But except in that condition that we'll get to in Chapter 4, you're always going to have a line to work with, so you can always apply this rule. And what this rule says is that if you have a statement on a line, you can write a disjunction where you have that statement that you already had as one of the disjuncts, and then the other disjunct can be anything you want. Okay? And your new disjunct can either go on the left or the right. Here, the disjunct I already had is on the left and the new one is on the right, but I can have it so that the one I already had is on the right and the new one is on the left. That's fine. Now you might say, okay, that's kind of fishy. Why can I just produce a disjunction that has this new disjunct that could be anything you want? Right, where did psi come from? Here's the way to think about this. Remember, the one feature that our rules have to have, the one goal they need to meet in order to be legitimate, is they have to be truth-preserving. Okay? Meaning if you apply it to something true, you have to guarantee that the thing it will produce is true. And you can see that this is truth-preserving, right? Because if phi is true, and it doesn't matter what phi is, it could be an atomic statement, it could be a compound statement, but if phi is true, then this disjunction is going to be true. Because remember, a disjunction is true if either disjunct is true. So if we know phi is true, then we know that this disjunct is true, so we know the whole disjunction is going to be true. And furthermore, we know that this disjunction is true regardless of what psi is. Psi could be anything. It could be an atomic statement, it could be a compound statement, it could be a contradiction. It doesn't matter. It can be any statement you want because it doesn't matter what it is. This disjunction will be true so long as we know that this disjunct here is true. Okay, so that's why that rule is okay. All right, let's see some examples. Now we've got 4 rules to work with. So here we have 4 premises. Conclusion we're trying to get to is R. Well, let's take a look and see what we could do. First off, we can apply DI, Disjunction Introduction, anytime, because we've got 4 statements here. So I could put 5, K or X, or I could have on line statement, I could have parentheses, if W then R, parentheses, or Z and not Z, right? So I could use DI. I just take any statement and make it one of the disjuncts here, and then the other disjunct is some other statement. Okay? But aside from DI, what other rules can we use? Well, disjunctive syllogism, we need a disjunction, and we don't have any disjunctions, so we can't use disjunctive syllogism. We have 2 rules that can use conditionals, right? We have modus ponens and modus tollens. Can we use any of them? Well, first let's look for modus ponens. To use modus ponens, we would need a conditional and we'd need the antecedent of that conditional. Here's a conditional. Do we have W by itself anywhere? No. Okay, we can't use it there. Here's a conditional. Do we have not S by itself anywhere? No. Here's a conditional. Do we have not W by itself? No. Okay, so we can't use modus ponens. How about modus tollens? Now for modus tollens, we would need a conditional, and we'd need the negation of the consequent. Okay, so here's a conditional. Do we have not R anywhere? Nope. Here's a conditional. Consequent is not K. Do I have K anywhere? That's the negation of this. Yes. Okay, so if I wanted to, I could do modus tollens on 2 and 4. What about here? Let's just check 3. There's a conditional. Do I have S anywhere? I don't. Okay, so except for DI, which you can always use, the only other rule we could use here is modus tollens on 2 and 4. Okay, so just to remind you, here's modus tollens. If I have a conditional and I have the negation of the consequent, I can derive the negation of the antecedent. So here's my conditional. I have the negation of the consequent. So this says I can derive the negation of the antecedent. Well, the antecedent is not S. Now, what is the negation of not S? Now remember, you can negate a statement by either subtracting or adding 1 tilde. Not 2, 1. Okay? Well, if this is not S, and I have to derive the negation of that, that means I could either put S, I take 1 tilde off and I get S, or I add 1 tilde, not S. Either of those would be fine. I'm going to go ahead and just put S. And I got that by modus tollens on lines 4 and 2. Okay. What next? Well, now notice I have this, which is the negation of that. So now I've got the pieces I need for modus tollens on 3 and 5. Okay. I have a conditional, I have the negation of the consequent, so I can derive the negation of the antecedent. Well, the antecedent is not W, so I'm going to negate that by taking 1 tilde off, and I'll get W by lines 3 and 5 modus tollens. Okay, and now, check it out. I've got the pieces I need for modus ponens up here on 6 and 1. Here's a conditional. Here's the antecedent. So by modus ponens, I can derive the consequent. So I can put R on a line by itself. And I use modus ponens on 6 and 1, and the proof's done because R was the conclusion that I was going for. Okay, let's do another proof. Here we have 4 premises, and what we're trying to get is not M. What I'm going to do right now, before I start on this, once you get practice with proofs, and I really recommend you practice a lot of proofs. There's loads of questions on online, loads of exercises with solutions online, because the more practice you get, the easier this is. You'll get faster, you'll get more accurate. But you'll also be able to do this. You'll be able to look at your premises and look at the conclusion and kind of figure out how your proof is going to go. Everything we've been doing so far is we've just looked at the premises, and every time we could see that a rule might apply, we've used it and derived new lines until we just managed to get the conclusion. We weren't really thinking strategically. We were just doing whatever we could and waiting until something good happened. And that's legit. You can do that, and a lot of the time, not all the time, but a lot of the time that'll work. But you could also think strategically. So I'm going to now say, okay, I'm going to try to get not M. How might I get that? Well, the letter M only shows up here in one spot, the antecedent of this conditional. I'm looking at this, I'm saying, you know, if I had W, if I had the negation of this consequent on a line, I could get not M by modus tollens, and then I'd be done. Okay, because not M is the conclusion. Well, how could I get not W? Well, that only shows up here. Again, if I could get the negation of this, I could get the negation of that, W, by modus tollens. Well, the negation of this, take this tilde off, would just be not P or R. How could I get that? How could I get not P or R? Well, if I could get not P, then I could get not P or R by disjunction introduction, right? How can I get not p? Well, not p shows up here. If I could get z or x, then I could do modus ponens to get not p. How can I get z or x? Well look, z is here, so I could just use di to get z or x. So what I've done there is I've just strategically worked backwards from the conclusion all the way back to something that I already was given as a premise. So now what I'm going to do is I'm just going to, if you didn't follow what I just said, don't worry about it. I'm going to do exactly what I just said, only I'm going to work forward. And then when I get to the end and the proof is all done, you'll be able to see, go back at what I just said, and it'll make sense. So the first thing I'm going to do is I want to get this antecedent, so I can do modus ponens to get not p. So I want z or x. And I know I can do that. Remember, here's the rule of DI. It says if I have a statement, I can write a disjunction where the statement I already have is one disjunct, and the other disjunct is anything I want. Well, here's a statement, and the other disjunct I would want is x. Now, according to the rule of DI, I could put anything here. I could put p, I could put r and not r, I could put any statement here. Why did I choose x? Well, because x is what is going to let me do modus ponens here, right? If this was p or if this was r and not r, then I couldn't use this with line 4 to get p, not p with modus ponens, right? So that's why I chose x. Well, look, now I can use modus ponens. I have a conditional, I have the antecedent. So by modus ponens, I can derive the consequent. So 4, 5 modus ponens gets me not p. Okay. Well, now what I want is I want not p or r. Why? Because if I get not p or r, that will be the negation of this consequent, which is not p or r. And if I have the negation of this consequent, I can then do modus tollens on this conditional to get the negation of the antecedent. I'll get w. And when I get w, I can do modus tollens to get not m, and I'll be done. Okay, so not p. I'm going to go not p or r. That's by di on line 6. Now this is the negation of that, right? If you negate this statement, you put parentheses here, add a tilde, that's what that is. So this is the negation of that. So I can do modus tollens on 7 and 3 to get w. I have a conditional, I have the negation of the consequent, so I can derive the negation of the antecedent. Okay, and now this is the negation of that consequent. So by modus tollens again, I can get the negation of this antecedent. So this is m, I can get not m. And that's by modus tollens on 2 and 8. And not m is the conclusion. Okay, so that proof is finished. Let's do another one. Okay, so last time I sort of worked backwards, which is fine. If you can do it, you can kind of think backwards through it. Or if you're not that familiar with the rules, in order to think backwards, you kind of have to be pretty familiar with the rules, and you have to have some experience under your belt doing proofs. But you can also just sort of apply the rules and hope something good happens. That's also fine. So let's do it that way. What rules can we apply here? Well, remember, we can always do disjunctive or disjunction introduction. It's not obvious that there's anything useful we can make with DI right now. So let's look at some other things. Can we do modus ponens? Well, these are conditionals. Notice there's a conditional here, but this line is not a conditional. This line is a negation of a conditional. So we can't do modus ponens on this, right? In order to use a rule on a line for an inference rule, we have to use them on whole lines. So the only entire lines here that are conditionals is 2 and 3. Do we have not S or R anywhere? No. So we can't use modus ponens. How about modus tollens? We'd need the negation of consequences. Well, do we have L or not G? No, we don't have either of those. So we can't use modus ponens, can't use modus tollens. what else? What else is a possibility? Disjunctive syllogism. Well, we have a disjunction. Do we have the negation of either disjunct? Do we have not L anywhere? No. I mean, not L shows up here, but it's not on a line by itself. So do we have not if G then R? Yes, we do. So we can do disjunctive syllogism on 1 and 4 to get L. We have a disjunction. We have the negation of the second disjunct, so we can derive the first disjunct. Okay. And notice this is kind of a common theme. Before we couldn't do modus tollens because we didn't have the negation of any of these consequents, but now we do. The piece we derived, this is the negation of that consequent. So we can do modus tollens to get the negation of the antecedent. We can get S by modus tollens on 2 and 5. Okay, now what can we do? If you look at these, what can we do? Now is a time when DI is actually useful. Just look at the conclusion. Conclusion is a disjunction. And DI will produce a disjunction, right? If we use the rule of DI on something, the result of that is going to be a disjunction. The thing we need is we need one of the disjuncts, right? Do we have this disjunct? No. This is close, but it's not the same. This is if R then G, this is if not R then G. So that's actually not that disjunct. But we do have this one, right? We do have the second disjunct. So we're home free. The rule of DI says that if you have a statement, you can write a disjunction where the statement you already have is one of the disjuncts, and the other disjunct can be anything you want. Well, what do I want? I want this, because if this is the other disjunct, then my proof's over. I'm done, right? And I can go home, right? Have dinner, order pizza. So that's the disjunct I want. Okay. What I want to do now is to say a little bit about what you can't do when you're applying inference rules. So we've got some examples now, and so hopefully this will make more sense. So these are some common mistakes, some things people do that you shouldn't do. So here's one thing you have to make sure. Whole lines in the rule have to correspond to whole lines in the proof. And I've already talked about that a few times, but I want to make sure that this sinks in. So look here, this is, here's just a pretend proof, right? We've got, these lines are already up here, and someone derived A from lines 1 and 2 with modus tollens. And this is fine, okay, because we have a conditional, we have the negation of the consequent, so we can derive the negation of the antecedent. The antecedent is not A, I can negate that by taking off 1 tilde. That's fine. Here's what I couldn't do. Suppose what I had was this. I couldn't say, oh, look, I can do modus tollens here because I have a conditional, and right here I have the negation of the consequent. Well, no, the reason you can't do that is because modus tollens says you need the negation of the consequent, but that negated consequent has to be on a line by itself, and not Q is not on a line by itself, so I can't, right? I would need Q, I would need not Q, not a disjunction where not Q is one of the disjuncts. So I can't do that. I have to put this red X here so that if people just download the slides, they won't just see this and go, oh, that's great. Right? They'll hopefully see the red X and know that you can't do that. Okay, so the lines in the rule have to correspond to whole lines in the proof. Second thing you have to do, the operators that are specified in the rule, okay, conjunction, disjunction, conditional, whatever, they have to be the same operators that are in the statements that you're applying the rule to. Okay, so what do I mean by that? Again, here's modus tollens. We have a conditional, we have the negation of the consequence, so someone derived the negation of the antecedent. That's fine. Here's what you can't do, and sometimes people ask, they say things like, oh, can I do modus tollens on a disjunction, right? So notice here I have a conditional, but here it's a disjunction, and the person is thinking, oh, can I just, if I have a disjunction and I have the negation of the second disjunct, can I derive the negation of the first disjunct? And the answer is no, right? If the rule specifies that this has to be a conditional, then the line on the proof that I'm going to apply it to has to be a conditional. If it's a disjunction, you can't use it. Okay, so another X there. Don't do that. Next thing, when you're negating something, make sure that you negate the correct thing, right? When you're thinking of negations, either adding or subtracting one tilde, make sure that you're adding and subtracting the tilde to the right statement. What do I mean? So here's somebody trying to do modus tollens, again, on 1 and 2. We have a conditional, we have the negation of the consequent. So according to modus tollens, we could derive the negation of the antecedent. The antecedent is this disjunction. So the negation of the antecedent would be not A or B. Well, what this person did is they just wrote A or B and then kind of stuck a tilde in front. And this isn't right, okay? Because why? Because this tilde isn't negating the disjunction. This tilde is only negating the first disjunct, okay? The result of modus tollens here would be the negation of the antecedent. It would be the negation of this whole disjunction. So you would have to write, so don't do this, it would have to be this, right? The negation of the antecedent. This is correct. Not that, that. Okay. Next thing, don't distribute negation operators. Okay, what does that mean? Well, let's go back. So this is the thing we just had, which is right. Conditional negation of the consequent, so we wrote the negation of the antecedent. The antecedent is the disjunction, so we negated the disjunction. That's fine, not A or B. Sometimes people look at not A or B and they think that that's the same thing as not A or not B. Okay, so they're kind of thinking that these are equivalent, and they're not. Okay, not A or B is not equivalent to not A or not B. Do a truth table for that if you don't believe me. So do a truth table for these two statements and you'll see that they're not equivalent. Same thing applies to a conjunction. Okay, so don't do that. Same thing applies to a conjunction. Not A and B is not the same thing as not A and not B. Again, do a truth table if you don't believe me, but those are not equivalent. Now you can kind of distribute tildes, as we'll see in chapter 4. There's a rule called De Morgan's that will let you distribute tildes, but what you'll find out is that if you distribute a tilde into a conditional, you have to turn the conditional into a disjunction. And if you distribute it into a disjunction, you have to turn the disjunction into a conjunction. I'm sorry, if you distribute a tilde into a, if you distribute it into a conjunction, you have to turn it into a conditional. God, I keep saying the wrong thing. Here's what I wanted to say. The thing you can do legitimately that we'll get to in chapter 4, don't do it now, but just in case you're thinking, hey, it seems like we ought to be able to distribute tildes. You can, but if I distribute the tilde into a conjunction, I would have to change the conjunction into a disjunction. I'd have to change this dot into a wedge. And if we go back here, if I distributed the tilde into a disjunction, I'd have to change the wedge into a dot. But don't worry about that now. The thing for now is just don't distribute tildes like this. Okay, so those are things you can't do. You should not do those. You'll lose points if you do those. What can you do? These are some things that people sometimes think you can't do, but you really can. The order of the lines in the rule doesn't have to be the same as the order of the lines in the proof. Okay? Except, of course, the derived line does have to come at the end of whatever you're doing. Right? So here's modus tollens. In the written schematic, we have the conditional above the negated consequent, just like here. But this is fine, right? Even though here the negated consequent is above it, all the rule says is you need these two things. It doesn't care where they are as long as you've already got them somewhere up above the new line you're deriving. Okay. So here they're in this order, here they're in that order. That's fine. You can cite the lines in any order you want. So here's modus tollens again. this could be 1, 2 modus tollens, but I could also cite 2, 1 modus tollens. So the order that these lines appear in doesn't matter. What matters is that you've got the rule and you've indicated the lines you've applied the rule to. Okay. We haven't got these two rules yet, simplification and conjunction, but I'll just go ahead and tell you now. For simplification, you can simplify either conjunct off. And when you do conjunction to join two things into a conjunction, you can put the two conjuncts that of the conjunction you just created in either order. Okay. So here's disjunctive syllogism. I talked about this when I introduced the rule, but I just want to go through it again. I could have the negation of the first disjunct and derive the second, but you could also have the negation of the second disjunct and derive the first. Either of those is fine. And for here's simplification. Okay, so those are the things you can do. And I'll explain what you can do with simplification now that I'm introducing the rule. So here's our two final rules. I'll introduce the rules, go through a couple of examples, and then that'll be the end of this video. The rule of simplification says that if you have a conjunction, you can take either conjunct and put it on a line by itself. And here in the written schematic, it was the second one, but you could also put the first one on a line by itself. That's simplification. The rule of conjunction says that any two statements you already have, you can make a conjunction on a new line where those two statements you already have are the two conjuncts. You can just sort of combine those two statements into a conjunction. Okay, so now we've got all 6 rules. We've got modus ponens, modus tollens, disjunctive syllogism, disjunction introduction, conjunction, and simplification. And the way you can remember these is that 2 of them deal with conditionals, modus ponens, modus tollens. 2 of them deal with disjunctions, disjunction introduction and disjunctive syllogism. And 2 of them deal with conjunctions, simplification and conjunction. Okay, let's do some proofs. One thing you can always do, if you don't see what to do, is to if you have a conjunction, you can just simplify the conjuncts off. So I'm going to go ahead and do that now. And I'm going to go ahead and simplify both of them. So I'm going to simplify the second one off. That's G by line 2 simplification. And I'm going to go ahead and get not D also. Turns out I'm going to need both of them. But even if I didn't know that, I might just go ahead and simplify both of them right now anyway, just in case. Why not? Because remember, the more pieces you have, the more things will become apparent. And notice, already I see, hey, I can do disjunctive syllogism. Oh, by the way, here's the thing you can do with simplification. You can simplify either conjunct. And notice, actually, I simplified both. First I did the second one, and then I did the first one. Okay, so even though the written schematic here, it's only the second one that you simplified off, you can simplify the first one too. Okay, well, when I got not D here, that was the negation of this disjunct. Okay, so I have a disjunction, I have the negation of the first disjunct, so I could derive the second disjunct on a line by itself by ds, if E then not G. And that's 4-1 disjunctive syllogism. Okay, now, is there anything we can do? Yes. This is where practice comes in. The more practice you have, the better you'll be able to just look at the statements there, and the moves you can do are just going to kind of pop out. You won't have to think about it. You'll just kind of see them. They'll kind of like they're flashing red. They'll just kind of be apparent to you. Notice I have a conditional, and I have the negation of the consequent. So by modus tollens, I can derive the negation of the antecedent. Okay, antecedent is E, negation of that is not E by modus tollens, and look, I'm done, because that is the conclusion. Okay, let's do another proof. here we have 5 premises, and what we're trying to get is not J. Well, there's a number of things we could do. Again, if you just look at this, once you get familiar with the rules, you'll just start seeing things. I've already seen, look, I've got this, I've got the negation of the first disjunct here, so I could get the second disjunct by ds. I've got a conjunction, I could simplify off these conjuncts. So already I'm seeing a couple of things I could do. I'm going to go ahead and simplify off some conjuncts here. I'm going to simplify this first conjunct off. Why not? Maybe I'll need the first one too, if so I can simplify it later. Now I'm going to go ahead and do the disjunctive syllogism. All right, I've got a disjunction, I've got the negation of the first disjunct, so I can derive the second disjunct. Okay, now you might look at this and say, hey, that's a weird statement, H or H. You're right, that is a weird statement. Doesn't matter. It's a disjunction. Just because both disjuncts are the same, whatever. We can still apply rules, we can still do the proof. So don't start looking at things and start overthinking it. Okay? Just get good at applying the rules and deriving conclusions. Okay. Now what can I do? Is there anything that's popping out as something that you might be able to do here? Sure. A couple of things. We could always simplify off this first conjunct if we wanted to. But notice that this is this antecedent. Okay, I have the antecedent of this consequent, so I can, or of this conditional, so I can get the consequent by modus ponens. Consequent is if H then R. So if H then R, and that's by 6,4 modus ponens. Okay. Now I'm going to go ahead and simplify off this first conjunct here. Why am I going to do that? Well, you'll see. What can I do now? Or let me frame it this way. And again, this is something that you'll be able to see when you get confident with the rules. You've done a lot of practice. I'm trying to get not J. That shows up a few places. If I could get R and D, well, I've got D here, but how could I get R? Well, if I could get H, I could get R, and then I could do conjunction to get R and D, and then I could get not J by modus ponens. Okay. How can I get H? Also, notice if I could get H, I could just get not J directly, right, by modus ponens here. So I'm thinking, how could I get H? Well, look at this disjunction. The first disjunct is H, right? Now I know that if I had the negation of the second disjunct, I could get H by ds, right? So if I had, anytime you have a disjunction, you can always get one of the disjuncts if you have the negation of the other disjunct by ds, right? Well, first disjunct is H. So if I had the negation of the second disjunct, I could get H by ds. How could I get the negation of H? I can get it right here. Modus tollens on 8 and 9. So I'm going to do that. I have a conditional. I have the negation of the consequent, so I can derive the negation of the antecedent, not H, right here. And now look, oh, here on line 10, I have the negation of this disjunct. This is H, this is not H. So I have the negation of the second disjunct. So disjunctive syllogism says then I can derive the first disjunct on a line by itself. So now I've got H. And now I can do modus ponens on 11 and 6 to get not J. Okay, so I'm going to talk about this one. This is the last example for this video. I'm going to do one more video for sections 3.5 and 3.6. That'll be next. But I want to say a few things about this proof. First off, the important thing is that every single line we derived was legitimately derived by the rules. Okay? You can go back and you can look at every one of these justifications, look at how we got it, and you'll see that it's fine, okay? So that's the first thing I want to say. Note, the one thing you might get hung up on is you'll say, well, wait a minute. With disjunctive syllogism, I thought that the two disjuncts had to be different. Ha! They don't have to be different. Okay, let me see if I can go back to the rule of disjunctive syllogism let me see, this is slide 140 we're on now. Where did I introduce disjunctive syllogism? Way back here somewhere. Okay. Here, disjunctive syllogism. And let's look at this is the written schematic. This is the verbal version of the rule. If you have a disjunction on one line, and you have the negation of one of the disjuncts on another line, you can derive a new line consisting of the other disjunct. Now, if you look at first off, just notice, if you look at the verbal description of the rule, nowhere on here does it say that with your disjunction, the two disjuncts have to be different statements. Okay? They could be the same statement. No problem. Now, you might say, well, gosh, maybe the written version says that, but look at the visual schematic. Phi and not psi, these are different Greek letters. Doesn't that mean they have to be different statements? No, because remember, the Greek statements are variables, and the variables can stand for anything. Now, the one thing you have to keep in mind is that no matter what phi stands for, phi is going to stand for the same thing no matter where it shows up, right? If phi is r, it's going to be r here, it's going to be r here. So it'll be r or something, and it'll be not r. But every time you've got the phi, it's going to be the same statement. And psi here is going to be the same here, right? So no matter what psi stands for, it can stand for anything, but it'll be the same thing in both of these locations. But notice that these don't have to be different. And think of it this way. Suppose, I wish I could write on this. It's probably not going to let me change this. Let me see. Well, you'll just have to listen. Suppose you had you were doing some math, right? And you had the equation for the area of a rectangle is height times width, okay? So h times w is your equation for the area of a rectangle. So if it's 5 feet high and 10 feet wide, it's going to be 5 times 10 is 50, right? And in that equation, h and w are variables, right? But notice variables could be the same value, right? You could have a rectangle that's 5 feet high and 5 feet wide, and then h would be 5 and w would be 5, and the equation still works, right? So when you have variables, they could be different values. H and w, the height and width, could be different, right? H might equal 5 and w might equal 10. But they could also be the same value, right? Maybe it's 5 feet high and 5 feet wide, right? Same thing with disjunctive syllogism. These variables can stand for any statement. In particular, phi and psi might both stand for h, right? So let's go back to 140, which was here. Here we have a disjunction. This will be phi or psi, but in this case, both phi and psi stand for h. So if this is phi, this is psi, this is not psi, and this is phi. So it still fits the pattern. Okay. The second thing, actually this is the third thing I want to say is, so the first thing was, yes, we derived everything legitimately. Second thing was, yeah, even if you thought this was weird, it's not weird, okay? Third thing you might think is weird is, hey, wait a minute. Look, we managed to derive not h and h. Isn't there something wrong with that? Well, there is something interesting about that. So think, what does it mean if we could derive a statement and the negation of that same statement? Why is that making you feel something might be fishy here? Well, what it means is that, think again in terms of our rules being truth-preserving. Okay? The rules are truth-preserving. What that means is that if we apply them to only true statements, we'll only be able to derive true statements. Okay? But look, these can't both be true. If not H is true, then H is false. And if not H is false, then H is true. So these can't both be true, yet we derived both of them. So we don't know which one of them is false, but we know one of them is, which means that somehow we managed to derive something false. And you might think, well, gosh, I thought the rules were truth-preserving. And you might frame it this way. You might say, but truth-preserving rules don't let us derive false things. But we know we derived something false here, so something went wrong. No. Here's where that line of reasoning went wrong. If you thought, oh, the truth-preserving rules mean we can't derive false things, that's not exactly what truth-preserving means. What truth-preserving means is you can't derive false things if what you are applying your rules to are all true. Okay? However, if the stuff you're applying your rules to aren't all true, then the fact that the rules are truth-preserving makes no guarantees, right? So what this means, the fact that we derive something false, this means that our premises aren't consistent. At least one of these premises has to be false. So the things we were applying our rules to can't all be true. That's the only way we would be able to derive something false, is if there was something not true in our premises. Our premises couldn't all be true. In fact, if you do a truth table for these premises, you'll see that they're inconsistent. Okay, but that's fine, because remember, if your premises are inconsistent, then anything follows. They will validly imply any conclusion. So the fact that we could derive the conclusion, we've still shown that the argument's valid. Okay, in this case, it's valid because the premises are inconsistent. So no problem. All right, so that's it for this video. The next video will be sections 3.5 and 3.6.